Hi, this is Abdul Khan, and this is lecture number 14 of my Basics of Microwave Propagation. So, if you remember, we are discussing diffraction loss from last 3-4 videos. So, I have reached almost the end of it. So, we learned that what is diffraction, how it is produced, how it is calculated. We saw that it's a very complex mathematics. So, we came down to make some approximation, because my point is that the viewer of my videos, they should at least learn something. They should get some idea that will give them a kind of edge on other people, that they know that what kind of things can be approximated in what way. For example, if you are doing the initial planning of a lot of sites and you have a lot of plan of sites reports, so if you have these things in your mind, then it will make your actual planning time very much easier. You don't have to plan all the line of sight candidates. You can just see some candidates. You can just drop some candidates just because of your knowledge of the terrain, and when you see the terrain, you can get that. You don't have to go in detail, because path loss also takes some time. I mean, you have to make a lot of files. So this will give you some initial idea that, for example, if you have some smooth earth kind of things in between, then how you can distinguish, how you can know that, okay, how you will treat it, or how path loss may be treating it, and what kind of approximate losses will be coming because of that. So based on that, you can choose the best of the alternates that you have. So coming to the main point, so basically smooth earth diffraction approximation, because as we saw the knife edge previously, so this is the second type of, which is called smooth earth or flat earth. So diffraction over a smooth spherical earth, or smooth earth diffraction. So here in this illustration, if you see the gray area, this is your main incident path going within this, and this gray full is your Fresnel zone. So for example, this is the smooth earth. The earth radius is, like, for example, here. So if you have a link where the first Fresnel zone is kind of partially obstructed, some part of it, because telling how much is some part of it is not very easy, but it's approximation. So up to 10 dB loss can you approximate if it is going through below the half of it. I mean, it's obstructing some part of it. And if you make a kind of correlation with knife edge, a knife edge which is coming on the similar place may have only 1-2 dB diffraction loss, because knife edge is very less. I mean, it don't have a lot of area. But here, if you see that even very little part of Fresnel zone is passing through it, but because the area of this earth is too much, still it's giving you approximately 10 dB of loss. But for example, your link, the Fresnel zone is passing through, almost half of the Fresnel zone is getting blocked. So you can have up to 20 dB of diffraction loss. So we can say that the flat earth is more critical for a link than the knife edges. Knife edges, maybe more than one knife edges, even if they are there, they may be having less impact than a flat earth which is stopping half of your Fresnel zone. And if you see here, if the full Fresnel zone is gone, for example, somehow, so your incident, your main ray is also gone, your full first Fresnel zone is gone. But as we know that still where we have the second Fresnel zone and third Fresnel zone, so some power will still be going, but it will be giving you a very significant 40 dB of loss. And as we know that some of the links, when we create those links, generally 40 dB, 50 dB is the total fade margin that you have, which is for the rain as well. So here we can see that if the scenario may be somewhere that your first Fresnel zone will be fully obstructed by a smooth earth, then it can wipe out all of your fade margin. So when you are creating a link, when you are designing a link, you have to see that because maybe you have a link that for the k is equal to 4/3 you are passing through this area, but when the k value increases and the earth became more bulgy, then this can lead to a total blackout of your link. So this is why sometimes some of your link they go in blackout for some time. So this you have to be very careful. And let me show you that how you can distinguish and mean what kind of area you will say that okay, this may be a smooth earth. Like in knife edge also I show you there was one last picture where we have a lot of 13, 14 knife edges. So that may also be approximated as a flat earth. But for example, if you have these kind of places, like if you see pass laws may approximate this as a single knife edge as well, based on, for example, this is not exactly passing from here, but if you see here, if the k, if for some values of k, if the actual ray is the Fresnel zone is passing through this area, like for example from here and here it is passing, then you can see this is a very significant earth. I mean this, so this may be approximated because your Fresnel zone is passing through a very long earth area. So this may be approximated as a flat earth, and in some cases this may be approximated as a single knife edge as well, or two knife edges. Maybe if it is passing from here, then it may be calculating it as two knife edges. So it may be approximated anything. I mean, mostly it may be approximated, for some values it may be approximated as a flat earth, and for some value it may be approximated as two knife edges. But if we see this kind of terrain, so here if you see there is basically no tower or no knife edge type of thing anywhere almost. You can approximate these two, but these are very small, and these are buildings. These are not the actual earth. So we have only one trap. There is no knife edge of anything. So this area is most likely to be understood by path laws as a smooth earth, and it will use it as a smooth earth. And if you have to mitigate, if you must go through this area somehow, then you have different ways. Like for example, you can increase some of the tower height if possible. Also, I have used a very low frequency. You can go to a bit higher frequency where the first Fresnel zone just passes through this beautiful area. So even in some extreme cases, it may drop up to here. I mean, the earth can come, the earth bulge can become obstruction for some time, but most of the time, if you have a high frequency which is passing through this area, then it will be a kind of fine link for you for most of the time. But my point was to show you that, like for example, this kind of terrain, because it has no tower type of shape anywhere, so this will most likely be treated as a smooth earth or a flat earth by path laws. So I hope that this video was beneficial for you. We have finished the diffraction lectures and we will go to refraction now. So I hope you will like it, you will learn from it. My point is only to guide you, to give you some ideas, and that how you can plan your link, how you can work on your link. So keep commenting, keep posting, keep watching my video and share it with your friends as well. See you in some other video. Goodbye.